still 10 minutes left for questions. Are there any questions from you? Otherwise, I have tons of questions. I will start asking them. Possibly, because we don't have a microphone, possibly you can use for answers the microphone which is in front of you. So the first thing that I was thinking of is that DOIs are already available for 10 years right now to publish data. We have several million data sets published already, and my question is there kind of saturation? Are we at a stage where when it started in 2004, have we reached a state where we want what we would like to reach, or is there something more to come? Are there big gaps yet? Did you identify a lot of problems, or are you satisfied?
We're not even close. We haven't even touched the tiniest snowflake of an avalanche of data. Be careful about assigning DOIs. DOIs have been very effective in the science journal literature, but their application to data sets, as Jens said, is what? 5 years, 4 years, 5 years, 6 years. And they're being used effectively as labels, okay, to track. But this idea of quality-controlled, published data sets is infancy. So you can find a data set with a DOI, but even there, across the range of geosciences, we haven't even touched a fraction of the data set. I hate to think about how little we've done. And if you then ask the question, as a researcher, which of those can I use because it's got a good description, because it's been published in Scientific Data or ESSD, we're even a fraction of that. So it's unbelievable how far we are from a good description of data. We're not even in the right universe for that.
Okay, then the next, it's directly connected to the next question is, it seemed to be that normally I would think, especially following what Michael was saying, I would think when I publish my data, I put something to the data and make quality controls to a certain process and maybe get a certificate or something like that, and can publish the data alongside with some documentation or relevant metadata so that it can be reprocessed or reused by others. The more I think about that, it seems to be that the data sets itself are published, maybe get a DOI. If you're happy, then there's a kind of quality process in advance that makes sure that the data has high quality. But it seems to be that the journals, the data descriptors and data articles, as papers about the data, are really required to ensure that the data sets have the quality that is requested in science. Is this why these papers or journals exist?
Yeah, and I think here you see a very close consistency. I like the way Andrew put this. We want the next user, who may, exactly as Michael said, be completely out of your field, to be able to reproduce exactly what you put in that figure or that spreadsheet or that time series or that summary. And to do that, we must give them not only the original data, but the tools, the criteria, what. And often in a data supplement attached, and I publish that way, you don't go into that. You don't go. I'm not saying you have to go into that for every article, but often you don't go into that. But for important data sets, some fraction of the total data sets, it is important to go into that. And even though we like to think we're smart enough to do it on our own, it's always true that having a second set of eyes will help you. I mean, that's how we do science, but in data. Hans mentioned this idea. We had this idea that living data, right? You do a global carbon budget in 2012, you just update the numbers in 2013, and it'll go smooth. In fact, if you look carefully, something new will emerge, a new idea, they want to use a new figure. So that second set of eyes, the review process with both both ESSD and scientific data emphasize, adds enormous value and credibility to those data sets. And it's the data description article that actually conveys that.
Yeah, I'd like to comment on that for a brief bit. There are, I feel weird with my back to them. Well, everyone can hear me, it's a small room, right? There are some communities where data is so standardized that you can just run it through a standard bit of software and you'll get a report out. And that's all anyone needs to see to know, hey, I trust that data. This is true for, I think, small molecule structures. You know, there's a journal, it's called a journal, Acta Crystallographica D or E, it's E, which is basically, you know, you have your small molecule structure, you run it through a program, it's going to generate this automatic report, and you pretty much publish this as a paper. And the Thomson Reuters basically threw it out because they said, this is too standardized, right? And so this is actually, I think we should say this is kind of nice, because this is a community that's got its crap figured out, you know? But it's also a field that's 100 years old. And so I really see scientific data and ESSD as being for that cutting edge, you know, the unique data sets. There's always going to be things where there's not going to be a bit of software that's going to say yes or no. And I think that uniqueness means, you know, we're never going to go out, run out of things to chew on, I think. And peer review is needed for those more unique, not necessarily big, right? It doesn't have to be gigantic. It just needs to be non-standardizable, and that's the vast majority.
Okay. So I can understand if I publish a paper, a data descriptor, data article, then this is my quality badge to the data which I have uploaded somewhere else. Right. Okay. Next question is...
sorry, Mark. I just want to throw a spanner in the works that we've been discussing similar quality issues for publishing software. And the software world sees things differently. They say, well, if you have code, put it out there. Yeah. If it's not reproducible, it's crap. You shouldn't have published it anyway. You shouldn't have published a paper if your code doesn't work. So put your data out there. That's your evidence. So that's a different approach. Yes, of course I want to reuse quality data, but from a reproducibility perspective, having what the paper was based on is also valuable. But then if I can then go and say, well, it has flaws, it has issues, that's also a scientific valid thing.
So the next question is, from your experiences, what are researchers and institutes are doing wrong with data publications and writing papers about it? And what are they doing right? Do you have great problems in getting contributions which just work right out of the box, or is there still a lot of more work done from your side as editors and reviewers than normally done for papers?
I'd like to hear Nature's view of this, but I'll give you a first. We've now published 120, roughly 120 data sets across a wide range of science. I think two things emerge. One is, none of those is a shortcut. Every one of those is creative, is challenging intellectually, requires the highest tools. So it's not like you're getting a cheap publication because you've put as much effort into that data description as you will have put in the journal paper. And the second point is, it's plausible. I don't know how far in the future we might think about this, but especially for some of these, like Andrew says, the custom assembled specialized data set, that it's not the science that drives the data set in the citation sense, right? The science is the product and the data is the supplement. I think you can see a future where the data itself is the publication, and then an array of science papers, you know, in a variety of journals flourish around it, and all of a sudden then the data descriptor becomes a central part, you know, becomes a urgent part. I think we're on the edge of that. Maybe in some fields that you work in, you're actually crossed that line. I'm not sure.
We would have to rewrite the research evaluation framework first.
Oh Oh, quite. And the fact that we bought into this, and Nature's going to buy into this as well, this whole, citation index and metrics is to a certain extent we're adopting from a different field something to the data field, and we may need to rethink some of that.
I fully agree with all of that, and I think the original question was, though, what problems are we finding in peer review with data sets? So I think the number one thing, and this usually doesn't lead to rejection, this is usually something that's improved during peer review, is think about other people understanding your data and the structure of the data before you We regularly get people that are good at writing relatively good methods sections and a relatively good narrative manuscript, and relatively good at then dumping a bunch of data into one of our repositories. But then our curator does a minimal, we're not getting too deep into the data, but she's got to understand your data files and how they connect to each other. We get plenty of times where people give us thousands of data files, which sometimes you have to do. And saying, well, you need to structure these intelligently for anyone to be able to get through them. And I think that's good advice. When you are collecting your data, at point of collection, you should be thinking about other people are going to use this. And if that means you need to spend an extra day thinking about how I'm going to structure, certainly, anyone who's ever written computer code knows that before you start writing any code, you should think about what your data model is going to be. And the same thing with doing an experiment. You should, even if it's just in your notebook, think about how you're going to encode the data well. And so that's number one. And that takes up a fair amount of peer review. I think number two is people coming, we have this amazing GUI, isn't it awesome? And our peer reviewers come back and say, I don't care about your GUI, I want to see the underlying data and I want it to be well structured. And then the last one is experimental design. If we reject a work, it's usually because our peer reviewers look at it and say, well, the measurements look sound, but the experiment was poorly designed, so I'm not going to touch it. And so, design your experiments well, or else nothing else matters.
Yes.
I would like to add something to this, and this is something from my experience doing biomedical research. It's most often you don't think about publishing the data. At least in biomedical sciences, in the labs I work in and the people I collaborated with, and there are quite a number, no one ever thought about the fact that you need to store data and process data in a way that other people in the end could understand it. It was mostly some chaotic folders on some PhD student's computer that contained all the work. And even them, if you ask them half a year later, can you go back, can you pull this data from this experiment for me? They would look at you and say, oh yeah, but I need a week. And then go through all these things. And you're laughing because you probably know similar situations. And often, some things are very, very quick shot. But it requires a lot of discipline, and it requires very, very different thinking to think about the way that you actually want to have this stored and you want to have this understandable by other people. And I think this is something that actually starts with the young people in this room. Right? This is something that starts, it's very hard to convince all the researchers to actually change their way. It took me a long time to talk to my PI to make her understand that it's crucial to publish a piece of code we use to process the data with that I wrote to do analysis. It was very hard for me to convince her that it's crucial for us to publish this code alongside our paper. I managed to do so in the end, but it's just a very, very different way of thinking if you think about using code and using data in your publication as equal components. As equal components, it's important to do science and important to reproduce what you've done.
Just before, I think coming towards the end of the discussion, but I want to add a very different aspect to this. We have talked a lot about reproducibility and about incentives and why it is important and good to be open and make things accessible. But in 2013, there was a really interesting work published by people from the California Digital Library who looked at who's willing to share data and under what conditions. And they did the usual thing, surveys, statistics on the surveys, and in all of that, that wasn't really new. The really new thing they did was they had a social anthropologist go into the research room and watch what people did. How do they behave? What might be their motivation? What might be driving their behavior? And what they found was that a very important part of scholarly culture is a gift culture. We give each other precious gifts, where we, sometime in the future, can expect something in return. In the old days, those were preprints of manuscripts, reprints, signed, of course. It could be references to talented students or postdocs, and data. Data are precious gifts. And so for a researcher, it would be nonsense to just put data out there for nothing in return. That would be squandering my social capital. Why should I? So to address that behavior, I think data publication and data as evidence to your publication plays an important role. Since publication is the currency, that's where you can get people. I call this tactic lurking at the water hole. They will pass. You will get them there. You'll have to wait, but you will get them. But I think these social aspects are something that we have to keep in mind when we think about how can we achieve more openness.
Okay, we will finish this short course here. I'm happy that the speakers have found the time to come, and I would be happy to see you tomorrow, same time, same place, and we're talking about scientific software again with great speakers. Thank you.